see how can we solve this question. Okay, in this question we have to calculate I of t and v of t, right? They have mentioned for t is greater than 0. I told you the steps also. What was the step number 1? Whatever they want to ask, we have to draw the circuit at t equal to 0 minus, right? That was step number 1. At t equal to 0 minus, we got a steady state condition. Steady state condition means from a long time current is flowing. There is no change in the current, right? So can you tell me that this switch, what does this indicate? That at t equal to 0, switch is closed or open? Tell me. Yes, switch is closed. Okay, but what that mean that at t equal to 0 minus, switch was open, right? So we have to draw for t equal to 0 minus, means we need to draw that switch should be open. Okay, I'm drawing the circuit again. Now the switch is open, rest of the things are same. Now the switch is open. Okay, this is the circuit, right? Now I told you at this point that capacitor will not behave like a capacitor if there is a steady state condition, means if from a long time current is flowing, right? If from a long time current is flowing in the capacitor, then capacitor will behave as a open circuit, correct? And if from a long time current is flowing across inductor, in this no inductor is present but I am telling you, then inductor will behave as a short circuit, right? So this is the capacitor, and as you can see that this in this case capacitor will behave as a open circuit, right? Clear? So this is also open. This we can mark it as VC 0 minus, because this is the condition for 0 minus, and at this point there is particular voltage across capacitor, right? So this one is how much? 30 kilo ohm. We can mark the values 30 kilo ohm. If it is in kilo ohm, you have to mark it in kilo ohm only. You can't change. Clear? Now this is plus minus Vt. What we need to calculate? That is V of t and I of t, right? This is I of t. Now can you tell me for this situation I of t is how much? Means I at 0 second, because we are considering for 0 second na? I0 is equal to 0 ampere only. As you can see that no current is flowing across this wire, right? Now similarly, can you tell me voltage across capacitor is how much? That is also, tell me, is there any voltage across capacitor? Yeah, why there is no voltage across capacitor? Can you tell me the reason? Yeah, if no current is flowing, then voltage is also 0, that is 0 volt, right? Now we need to calculate V of 0, means this one. Okay, means we need to calculate this one. Now tell me what would be the value for voltage across. Let us consider this one as A point and this one as B point. Now can we write on V of 0, that would be equal to VAB only. Now can you tell me what will be the voltage across A and B point? Yeah, resistance is 20 kilo ohm, correct? And Yeah, IAB. And how much current is flowing across AB? If we'll apply Ohm's law, like IAB multiplied by RAB, right? RA of B is 20 kilo ohm. Can you tell me, according to this circuit, what is the current flowing across A and B? That is 7 point milliampere, right? If we'll solve it, then we'll get the value of 150 volt. Okay, got it? Any doubt up to here? Okay, now this was the step number 1, that we have to find out the condition at t equal to 0 minus, right? Next, I told you we have to calculate for step number 2, that is at t equal to 0 plus. Again, this is for the steady state, right? Now again we have to see the diagram. Okay, we have to redraw the diagram. Current source will remain as it is, resistance will remain as it is. Now at t equal to 0 plus, tell me, switch is closed or open? Switch is closed, because at t equal to 0 switch is closed. So at t equal to 0 plus also switch is closed, right? So we can make the switch closed, right? Again, if this is a steady state condition, capacitor will behave as an open circuit or short circuit? Capacitor, yeah, yeah. Always, if there is a steady state condition, you can write it down also. If there is a condition of steady state, okay, steady state means there is no change, then capacitor will behave as an open circuit, and inductor is this one, will behave as a short circuit. Okay, so this will behave as an open circuit, and rest of the diagram will remain same, that is 30 kilo ohm, 20 kilo ohm, and 7.5 milliampere. Clear? Now tell me any doubt. Now this is we can consider here it as VC of 0 plus, right? So can we calculate VC of 0 plus 0 plus? So sorry, this is VC. The VC we can consider at infinity, like we just mark it as VC. Now can you tell me VC is how much? Like we can mark as A and B. So VC is equal to VAB, right? Hmm? Now can you tell me VAB is how much? As you can see that you are standing at A position, you have to move to B, right? I told you we have to calculate voltage by this formula only. So you can go through which path? VAC plus, tell me. Yes, this one and this one is, yeah, VDB is also 0, because is there any current flowing across 30 kilo ohm? No. So VCD we can consider ICD multiplied by RCD. Yeah. So again we got the same value. ICD is 7.5 milliampere multiplied by RCD is 20 kilo ohm. That would be 150 volts, right? Any doubt up to here? No. We can consider t equal to 0 instead t equal to infinity, because from the long time current is flowing now So that's why we achieve steady state condition. Okay. Now in the third step, step number 3, we have to calculate at t equal to 0. T equal to 0 means the transient condition. Transient means at which point it is changing. Like I told you na, at t equal to 0 switch is closed. Okay. At 0 minus it was open, so that was steady state. Steady state means if there is no change in the switches. Okay. Like suppose you enter a room, this is your room, and when you enter a room you switch on the fan. Just the condition with when you switch on the fan, that is the transient condition, because you change the switch, right? And before that there is no change, that was steady state. And after that, like at t equal to infinity, switch is opened or closed. Infinity, like you are remaining in the room for 1 hour, so you are seeing the switch for 1 hour. After 1 hour, so switch is closed or open? It's closed, right? So that was which condition, transient or steady state? Steady state, because you are not changing the switch now. Clear? Now we are going to solve step number 3 at t equal to 0, that is the transient condition. Okay, again I am drawing the circuit. This is a current source, this is a resistance. Now the switch is closed or open? Tell me. Closed, right? At t equal to 0, because we are changing that. Earlier it was open. Now at the transient condition, if there is a capacitor, it will behave like a capacitor only. Okay. If there is an inductor, it will behave like a inductor only when you are changing the switches at the transient. Okay. Now the capacitor will behave like a capacitor, and resistance was there, right? This was V of t, this was 7.5 milliampere, this was zero point 0.1 microfarad. Okay, tell me any doubt up to here first. So in this they have mentioned in the question how much current is flowing, that is I of t, right? So we mark here I of t, and in the question they have mentioned that this is V of t, that is the voltage across 20 ohm. So can we mark here plus minus V of t, there I already marked, sorry, that was 20 kilo ohm, right? Now what we need to do, we need to calculate V of t and I of t, right? Remember the formula just I told you. What was the formula for V of t? The equation form. Yeah, formula for the V of t, that is how much V of 0 minus, right? V of 0 minus V of infinity bracket e raised power minus t by tau plus V of infinity. We can say V of infinity. Okay, right? This was the formula for V of t. What is tau here? Tau here is the time constant. If there is a RC circuit, then tau formula is R equivalent multiplied by, and if there is a RL circuit, then tell me the formula for the tau. Yeah, R equivalent over L. Okay, and what is the unit of time constant? Yeah, and this is for this is for, sorry, it's L by R, L by R equivalent. Okay, now we have to see the time constant for which condition, at t equal to 0 minus, at t equal to 0 plus, or at t equal to infinity. At no, at t is greater than 0. Yeah, okay. So we have to see that, do we know v of 0 minus? Let's check the condition. I told you that v, this is the voltage across capacitor now. So there is no change in the voltage across capacitor. That is Vc 0 minus is equal to Vc of 0 plus. Right? I told you now that if the capacitor doesn't allow the change in the voltage, means at t equal to 0 you switch the fan or off, switch off the fan. So earlier voltage was suppose 800 volt, and after 1 second the voltage will remain same. This is I'm saying just after 1 second, right? So Vc 0 minus is just 1 second before, and Vc 0 plus is just 1 second after. So Vc 0 minus, yeah, Vc 0 minus we have calculated for this condition, that how much we got, V of 0 minus, Vc of 0 minus, we can consider here at V 0 minus also, because this one is for the t equal to 0 minus, that is we got it as 150, right? Now we have to see for the V of the V of infinity. Okay, yeah, V of infinity, right? And we have seen what condition for also, Vc of 0 is, see in this case Vc of 0 is 0 volt, that was, sorry, Vc of 0 is 0 volt, and this one is 150 e raised to power minus t by tau. Tau we didn't know, we'll calculate it. And V of infinity is again how much, 150. Okay, yeah, V of z infinity, see we have calculated Vc is the voltage across infinity, that is 150 volt, right? Now see we have calculated at t equal to 0 minus, Vc 0 minus, see is there any current flowing across this? If no current means no voltage. Okay, so we can say that Vc of 0 minus, that would be equal to Vc of 0 plus, that would be equal to 0 volt only. Okay, this 150 volt is the voltage across resistor. Which voltage? That is 20 voltage across 20 kilo. Okay, any doubt up to here? First tell me. Okay, so now just one thing is left, that we need to calculate time constant, right? For time constant we have to see which circuit, the circuit at the transient. Okay, at t is greater than 0 we can consider this one, the transient circuit. Okay, remember I told you for calculation of time constant we have to remember the following steps. First we have to calculate it at t equal to 0, the transient condition. Okay, and for calculation of time constant, if there is a current source, that would be open circuit. Okay, and if there is a voltage source, that should be short circuit. Okay, short circuit is like this. And like I told you, the way of remembering also, current source is just like your friend. After seeing your friend, you just open the door. Voltage source is just like your relative. After seeing them, you just shut the door. Okay, next thing you need to remember, you have to calculate total resistance. Okay, and for calculation of total resistance, you will mark A and B terminal where either capacitor or inductor is connected. Okay, so you have to learn all these steps for the time constant. So what is our first step? That we have to take the circuit at t equal to 0 transient condition, right? So let's move to this condition. This is the transient condition, correct? Now move to our second step. Current source must be open circuit. So can we open circuit this current source? This is like this. Okay. Third, voltage source, short circuit. But there is no voltage source over here, correct? Then calculate total resistance, mark, and from where we have to calculate total resistance, mark A and B where capacitor or inductor is connected. Like there is a capacitor and inductor would also be open circuited. Okay, now mark A and B here. So you have to calculate R equivalent from these two terminals where your capacitor was connected. Clear? This was 20 kilo ohm, this was 30 kilo ohm. So just imagine that you are standing at A position and you have to move to B position. Okay, these are your friends. If two of your friends are in the same path, that means they are connected in series. If two of your friends are at different path, that means they are connected in parallel. Okay, now can you tell me these two resistances are connected in series or in parallel? These are in the same path or at the different path? See, you can go to both the house at the same time now. You don't need to divert your path. So they are in the series. R equivalent is equal to 20 kilo ohm plus 30 kilo ohm. That is equal to 50 kilo ohm. Clear? So can we put down value here of tau? Tau is how much? As I told you, R equivalent multiplied by the C. So tau is equal to R equivalent multiplied by C. R equivalent is how much we got? 50 kilo ohm. And capacitor value is how much? 0.1 micro. Now solve it and then tell me the value. You 5 milliseconds, right? So can we put down the value here? Tau is equal to 5 milliseconds, correct? So now can we solve it for further, like 1 by 5 millisecond? 1 by 5 millisecond is how much? 1 by 5 into 10 raised to power minus 3, right? That would be second. So can we write down 10 raised to power 3 divided by 5? that is 1000 divided by 5, that would be 200, right? So the final answer is 1 minus of 150. This is also 150 e raised to power minus 200t and plus 150, right? Now tell me, any doubt up to here? Hmm? The value of C is given in the question itself. See, they have mentioned now 0.1 microfarad. Okay, so final value we got it for the capacitor, that is V of t is equal to 150 minus 150 e raised to power minus 200t volt. We can take it 150 as common, 1 minus e raised to power minus 200t volt, right? Okay, now back to the question. See what they have asked. They ask you I of t means the current across capacitor. Okay, right? But what we calculated? We calculated voltage across capacitor, right? As I told you, whatever they ask you, for the capacitor, you always need to calculate voltage. Always calculate voltage. Okay, for inductor, always calculate current. Okay, like in this question, they ask you the current across capacitor IT, right? But we calculate VC of t, right? So how did we get I of t? I told you the formula now. Tell me what is the formula for the current across capacitor? Remember? Yeah. C. So C we have 0.1 microfarad d by dt Vc of t, or we can say V of t, whatever the value it is. That is the voltage across capacitor is how much? 150, 1 minus e raised to power minus 200t, right? Now can we solve it further? 0.1 as it is, 150, then you have to take the differentiation. Okay, if we'll solve it, then you will get the, yeah, we can write it down as 3 milliampere e raised to power minus 200t.